The U.S. Army has recently advanced a significant milestone in its efforts to modernize short-range air defense with the live-fire deployment of the SGT Stout system at Fort Hood, Texas. The exercises demonstrate the Army's commitment to addressing emerging aerial threats, particularly drones, low-flying munitions, and rotary-wing aircraft, which have increasingly challenged traditional armored and mechanized formations in recent conflicts. The SGT Stout represents a generational leap in mobile air defense technology, integrating sophisticated sensors, lethal firepower, and networked command systems into a single platform capable of operating within the fast-moving dynamics of contemporary battlefields. Developed under the Mobile Short-Range Air Defense (MSHORAD) Increment 3 program, the SGT Stout is built upon the Stryker A-1 armored vehicle chassis, providing the mobility necessary to maneuver alongside frontline units. Formal approval for limited fielding occurred in late 2024, with deliveries to select units commencing in early 2025. Among the first to receive the system is the 6th Battalion, 56th Air Defense Artillery Regiment, which has been actively participating in comprehensive live-fire evaluations. Unlike its predecessors, the SGT Stout is designed for integrated operations, combining a robust armament suite with advanced sensor and targeting capabilities to achieve rapid and autonomous threat engagement. The SGT Stout's primary weapon, the XM9 14-30mm chain gun, is capable of engaging both air and ground targets using programmable airburst munitions. This provides a level of flexibility essential for countering small, fast-moving aerial targets, including drones and loitering munitions. Complementing the chain gun, the vehicle carries dual Stinger missile launchers, offering multi-layer defense and extending engagement ranges. The platform also incorporates an advanced electro-optical and infrared sensor array, coupled with L3 Harris Integrated Fire Control Radar and Leonardo DRS Mission Command System. This combination allows the crew to rapidly detect, track, and engage threats autonomously, while maintaining seamless connectivity with other air and ground assets in the field. The Fort Hood exercises have emphasized both operational realism and adaptability, testing the SGT Stout in scenarios that simulate the complexity of modern combat. Crews faced multi-threat engagements, including drone swarms and simulated saturation attacks, while maneuvering under conditions of simulated enemy fire. Day and night operations were conducted to validate the vehicle's sensors, targeting systems, and crew coordination in varying environmental conditions. Unlike prior testing phases, which primarily focused on technical qualification at static ranges, the current exercises integrate the SGT Stout into combined arms formations, reflecting the Army's objective of achieving full operational integration within brigade combat teams. These developments occur against a broader strategic backdrop. Following the Cold War, short-range air defense had been largely deprioritized within U.S. Army doctrine, as the perceived threat environment favored long-range precision strikes and strategic deterrence. However, recent combat experiences, particularly in Ukraine and the Middle East, have underscored the vulnerability of mechanized units to drones, loitering munitions, and low-altitude missile attacks. Observations from these conflicts highlighted the urgent need for highly mobile, survivable, and responsive air defense systems capable of protecting maneuver units in dispersed and dynamic operational environments. The SGT Stout is explicitly designed to fill this capability gap. In comparison to legacy systems such as the Avenger, which were constrained by limited mobility, outdated sensors, and reliance on external targeting data, the SGT Stout represents a comprehensive modernization effort. It provides all-weather, 360-degree coverage while maintaining pace with armored formations. Its sensors fuse radar and infrared input to create a comprehensive situational picture, allowing the crew to engage multiple fast-moving targets within seconds. The platform's modular architecture also supports future integration of non-kinetic solutions, including directed energy weapons and electronic warfare modules, further enhancing its adaptability to evolving threats. The operational significance of the SGT Stout extends beyond its technical capabilities. By embedding a highly capable short-range air defense system directly within brigade combat teams, the Army ensures that frontline units retain organic protection against rapidly emerging threats. This represents a doctrinal shift toward decentralized, mobile air defense that complements existing strategic assets. In practice, this means that armored and mechanized formations can maneuver with increased confidence in contested environments, reducing their vulnerability to drone strikes and low-altitude missile attacks while maintaining operational tempo. The live-fire exercises also serve as a critical training and evaluation platform for the crews themselves. Operating the SGT Stout requires a high degree of coordination between vehicle operators, weapons officers, and command systems. The Fort Hood exercises provide a controlled yet realistic environment in which crews can practice rapid decision-making, target prioritization, and integration with other combat units. By incorporating scenarios such as drone swarms and simultaneous multi-axis attacks, the Army is able to stress-test the system and its personnel under conditions that closely approximate the uncertainty and complexity of real combat operations. The SGT Stout's digital backbone is a key enabler of its operational flexibility. Its integrated command and control architecture allows for seamless updates and modular upgrades without necessitating a full redesign. This future-proof design ensures that the system can accommodate emerging technologies, including directed energy systems and electronic warfare suites, which are increasingly viewed as essential tools for countering unmanned aerial threats. Such adaptability will be critical as adversaries continue to innovate in drone technology, loitering munitions, and low-altitude precision-guided weapons. Strategically, the Army plans to achieve full-rate production of the SGT Stout beginning in fiscal year 2026. This will equip multiple Stryker Brigade combat teams and National Guard air defense formations with a modernized, mobile short-range air defense capability. Interest from allied nations in Europe and the Indo-Pacific suggests that the platform could also have an export trajectory, particularly among NATO members seeking systems compatible with their command structures. By establishing a credible mobile SHORAD capability, the U.S. Army aims to set a standard for allied air defense integration while reinforcing forward-deployed units against evolving aerial threats. The SGT Stout's integration represents more than just a technological upgrade. It reflects a fundamental evolution in how the Army conceptualizes battlefield protection. In the modern operational environment, speed, mobility, and autonomous engagement capabilities are critical. Units equipped with the SGT Stout can respond to threats within seconds, maintain operational momentum, and operate effectively even in contested or degraded environments. This capability is particularly important in multi-domain battle scenarios, where threats can emerge from the air, ground, and cyber domains simultaneously. Additionally, the SGT Stout underscores the Army's commitment to learning from recent conflicts and applying those lessons to domestic force modernization. The proliferation of drones and unmanned systems in Ukraine, for example, highlighted the difficulty mechanized formations face when operating without organic short-range air defense. Similarly, operations in the Middle East demonstrated the vulnerability of supply lines and command elements to low-flying munitions. The Army's investment in systems like the SGT Stout reflects a recognition that modern warfare increasingly depends on rapid detection, autonomous engagement, and integrated air defense capabilities. From a tactical perspective, the SGT Stout enhances both survivability and lethality. Its ability to engage a wide spectrum of aerial threats protects not only frontline combat units but also logistical and support elements, which are frequently targeted in modern asymmetric conflicts. The combination of a high rate-of-fire chain gun, missile capability, and advanced sensors provides layered defense that can counter drones, helicopters, low-flying missiles, and other aerial threats with precision. By allowing mechanized formations to maintain mobility while under threat, the SGT Stout mitigates one of the most persistent vulnerabilities in modern armored operations. In conclusion, the live-fire exercises at Fort Hood signal a major step forward in the U.S. Army's modernization of short-range air defense. The SGT Stout system represents a fusion of mobility, lethality, and advanced sensor integration, enabling brigade combat teams to operate with increased confidence against increasingly sophisticated aerial threats. Its modular design, autonomous engagement capabilities, and future-ready architecture position it as a cornerstone of U.S. Army air defense for the next 2 decades. By bridging the gap between traditional kinetic systems and emerging directed energy and counter-drone technologies, the SGT Stout ensures that forward-deployed forces remain protected, adaptable, and capable in an era of rapidly evolving threats. The deployment of SGT Stout not only strengthens the Army's defensive posture but also signals to adversaries that U.S. forces are investing in agile, integrated, and technologically superior solutions to modern battlefield challenges. As production scales and integration expands across units, the SGT Stout is poised to redefine short-range air defense doctrine, shaping the operational and strategic landscape for years to come. Its successful incorporation into live operations will serve as a benchmark for the Army's broader modernization efforts, ensuring that mechanized forces retain both mobility and protection in a high-threat, multi-domain environment.